Yes, hi guys. And today the topic is that what is the volume of solid of revolution? Okay, volume of solids of revolution. Okay, first I'll take Cartesian equations. Okay, in the form of Cartesian equations. When Cartesian equations are given, and what is the volume of solids of revolution? A solid formed by revolution. Okay, if area is revolved around a line or axis, for example, axis of x, axis of y, then a solid is formed. And then what is the volume of that solid? So volume of solids of revolution. So volume of solids of revolution is the topic of today, and that I'll talk about what is the how to find it out and what is the process of this. Okay, that I'll talk about. Secondly, in Cartesian form, in case of parametric form, okay, when equations are in parametric form, when equations are in polar form, the equations are in Cartesian form. First, I'm taking Cartesian form, and when I'll take parametric form, then polar form, then I'll talk about okay the formula of that. But today I'll just introduce about them. Okay, what is the parametric form of the volume of a solid of revolution? So if a curve is given to us and that curve is occupying some area, okay, between that curve and the axis of x and some ordinates, okay, and sometimes if it is the y-axis, not x-axis, y-axis, and the curve, okay, between and the axis, okay, at x equal at y equal to a, y equal to b, and between these four things, okay, the curve y equal to a, y equal to b, and the curve, sorry, and the axis of y. This is that area will also be calculated. How to find out the volume? Okay, that area is revolved around that axis, and after that we find that what is the volume of that solid. So let me first generate what kind of this volume is and how this volume is generated. If I take, let me define this with the process is what. If I take a curve, let me take any curve here. Okay, let me take this curve. Now at this curve, if I take a point, let me take here a point, and here it is b point, let me take. Okay, and if I draw a perpendicular from A to the axis of x, this is axis of x here, origin O, this is y and y dash axis, x dash. Okay, now if I draw perpendicular from B also, then drop a perpendicular from B also. Okay, so this is here x equal to A. Here at this point x equal to A, and this is x equal to B. Okay, so this x equal to b here, we are taking x equal to a. That means this length is at this point, x coordinate is a coordinate, okay, and y coordinate will be fx here. Okay, so what is fa? That point is, this is between that. Now if I take 2 points on this curve, let me take p point and this is q point. Coordinates of p are x and y, let me take, and coordinates of, okay, if I just write in description, I'll write what are the coordinates of x, p and q, that I'll talk later. But before that, let me take only this is the p point here, this is q point. Okay, and if I draw perpendicular from p, let me take this is m point, and here it is n point, elementary strip, sorry, n point here, and this is point n. Okay, this is point n here I've taken. Okay, this is elementary strip, let me take, and if I draw perpendicular from p to qn and from q to pm or mp, then they are meeting at this point. Sorry, this is the curve here we have taken. Okay, and so this point, let me take R here, and this is, here it was P, and this is, let me take S here, PQRS. Okay, so these are the points. Now what is the, okay, volume here we have to find out what the volume means. Now here we have to find out that suppose this curve and this x-axis and these two ordinates, x equal to a and x equal to b, or these are two abscissas. Okay, this length and this length. This is y coordinate here, y coordinate. Okay, so but at x equal to a, between x equal to a to x equal to b, because on the axis of x, we are revolving this area between this curve x axis and these two ordinates x equal to a and x equal to b. So the area formed by a solid, okay, the area which is revolving around this x-axis will form a solid figure. That solid figure's volume we have to find out. The volume of that solid figure is to be calculated, and then what is the point here? So now let us take, let me write here. What is the volume of this? Is we are finding out to find volume of a solid of revolution. Solid of revolution, okay, obtained by revolving. Let me write here A, by revolving the area, A. Here let me take some point. I'm sorry, here x is okay, x equal to a, and here it is x equal to b, but I have to take some points here. Okay, at this point let me take m and q r s, or if I take here t and u, let me take this point is t and this is u, s t u. Okay, so the other points here. So between the area, what is the area here? A T U B, okay, and PS PA. This area is revolved around the axis of x or OX axis, and then the solid will be formed. Okay, so we have to find out the solid of volume of a solid of revolution obtained by revolving the area A T U B A around the axis of x, and between the curve AB, axis of x, and two ordinates, and the ordinates x equal to a and x equal to b. So the area, this area is revolved around axis of x, and then that volume is obtained. Okay, now let p x by and q x plus delta x and y plus delta y be the two neighboring points. We have taken here, be the two neighboring points on the curve AB. This curve, or let me represent this curve by y equal to fx. Y equal to fx is the curve. Okay, y equal to fx is the curve, and we have taken between them A and B points. This is the curve here, and this curve is y equal to fx. Okay, this is equation of the curve here, y equal to fx here. This is the curve, okay, between A and B. So A and B, between the A and B area, we have to form this arc is revolved around the circle on this axis of x, and then the solid is obtained, and volume of that solid will be what? That is our main objective here. Okay, so neighboring points on the curve AB. Then further let the volume, the volumes of solids obtained by revolving. Now I'm taking only ATMP. This is one particular part here, ATMP, and solid obtained by revolving this A, T, and Q. Okay, and Q, and total solid, that solid, so ATMP and AT and Q are V and V plus delta we are taken, or dV are taken. Okay, V respectively. Then dB or delta V is the volume, is the volume here, is the volume between what? Between A, T and Q and ATMP. ATMP. Okay, these areas which are forming the solid. Okay, volume between ATNQ and ATMP, areas revolving around the axis of X. Axis of X here. It means what is the, now this is the volume created by elementary strip P, M, N, Q, P. Okay, that is the dV or delta V volume. Delta V volume is the volume of elementary strip P, M, N, Q, okay, elementary strip PMQ, or this is elementary area, you may say, volume of elementary strip revolve around the axis of X. Now the point is this delta V. So what is the area of this? Now if I find out what is the area of this, first let me find out that this volume. So volume of the figure, okay, PMNRP is smaller than, so volume of area PMNR is smaller than, okay, this is PMNQP, area of PMNQ is smaller than, okay, volume of area SMNQ or MNQS. Let me take MNQS. Try to understand MNQS. Now this area PMNR, or this area when revolved around the axis of X, about this one, and this is delta X distance here, or you may say this is delta X here. The width of this is delta X, because this is X and Y coordinates of P. So this is up to this point, OM is X, OM plus N, or ON is X plus delta X. So this is delta X here, this distance, okay, and this is delta Y, this distance, delta Y. Okay, so what is the volume of, so volume of this one is y into delta x, y square into delta x. That is the volume of this. Or that circle will be obtained. So the area of the circle will be pi into y square into delta x. That means pi into y square into delta x is smaller than this. We have taken as delta v is smaller than pi into y plus delta y into delta x, pi into plus delta y whole square into delta x. Now let me write it here, then you can understand. So what I am talking about, that the volume created by the area M and Rp around this axis solid volume, that volume will be pi into y square. Why? Because this distance Pm is y coordinate of P. So this is this height, pi by square into delta x. Delta x is this width. Area is y square into delta x. Sorry, this is y into delta x. When revolve around this, so volume will be pi into y square, area into the distance between them, the length, area of the base into distance between them, or this width delta x is smaller than delta b, is smaller than this. I was talking about y plus delta y. Why? Because when the volume of the area which is revolved around the axis of x, this m and qs, so m q n is y plus delta y whole square into delta x is the width of this is also delta x. Now when q occupied p, when q tends to p, this implies that delta x tends to 0 then. So then delta x will not be there when q occupied p or q tends to p, and delta x tends to 0. This then that implies that delta y also tends to 0. Then that means volume dv upon dx, if I just write upon delta x, or let me write here that in this case pi y square is smaller than delta v upon delta x, is smaller than, if I divide by delta x throughout, it will be pi plus delta y whole square. Now in situation when delta y turns 0, okay, delta x turns 0, then delta y also turns 0, so this will also be 0. That means the volume will be, this implies that in case delta x tends to 0, in delta x tends 0, or when delta x tends 0, then delta y also tends to 0. Then delta y also tends to 0. This implies that the volume dv upon dx is equal to pi into y square. Pi into y square on delta y tends 0. This is y square only. So in both the cases, when this is delta v upon delta x lying between pi by square and pi by square, that means this is equal to pi by square. Okay, that means if I find the integration of this limit here, then the integration of this area, so from x tend to a to b, if I put the limits here, so therefore pi by square between the limits here a to b and x equal to a to x equal to b, this is equal to limits a to b. This is dv here. I have taken delta x to this side, or this is dx here. Now this is dx here. Okay, or let me write here properly. Pi by square into dx is equal to this, and this integration of this dv is v here. So this is a to b. This is equal to volume at x equal to b minus volume at x equal to a. Okay, so volume of this will be this, and this is equal to just the volume of the figure ABCD. ATUB, the volume of solid generated by area generated by area. What is that area? ATUB when revolve around this axis. So this is the area here, pi into pi square delta V. So let me write here. Therefore V volume is equal to A to B. This is pi into y square into ds. This is the basic formula when the curve is y equal to fx. Similarly, now let me write here. Similarly, when curve is of the form x equal to fy, in that situation the volume will be the volume generated by an area between the curve x equal to fy, the y-axis here, in this case y-axis, try to understand, and the x is such, and the x is see y is equal to, let me take c here, and y equal to d. Between these two, then volume will be what? Now if the curve is, let me write here curve, if the curve is of this kind, suppose this is the curve here, okay, so between these 2 points, here y is equal to c and here y equal to d here, let me take, and this is the curve x equal to fy. In that situation, this is x-axis and this is y-axis here. Again we will take here elementary strip, about this is p and q, okay, in this way we will take p and q. So this is elementary strip here. Again this is delta pi or delta pi distance between them. So the volume will be, in this case, limits c to d. This is y equal to c to d, and this is x square pi into x square into d pi. Okay, so this is the volume in case when y-axis is involved, the curve y-axis, and the x-axis y equal to c and y equal to d. Between these, this area, when revolved around the axis of y, okay, then that solid is obtained and the volume of that solid will be given by this. This is in Cartesian form we are talking about. Okay, now in case when parametric form is given, then what is the volume? So in case parametric forms are given, in case of parametric form, now in case of parametric equations, that is, you take x equal to ft and y equal to, let me take gt, then volume, okay, is given by the same formula we will apply here, that is pi into y square, limits here a to b we will take into ds, it was here pi by square into dx will be converted into, let me take here at x equal to a, okay, at x equal to a, t equal to t1, this is t1 to t2, two limits in terms of t here, t is the parameter here, Okay, and pi into y square is this gt, or this is gt square, gt whole square into dx dt into dt. We will take this point also. For dt we have to write here. So dx dt, so it was dx here. So we have to divide it by dt. We have to find out dx upon dt. Dx upon dt is f dash t. That means this will be equal to t1 to t2. This is pi. If I take outside, this will be gt whole square into dx dt is f dash t. F dash t dx dt into dt. So this is the formula which will be applied for volume of a solid generated by a parametric form of the equation. Okay, revolving around the axis of x, axis of y, or then if axis of y is there, then it is x square. So x square it is f dash t, ft whole square into this. In this case, this will be g dash t, or pi into x square. Here it was c to d. We have taken limits into d by. This will be given pi. Let me take outside. C again. It is suppose t2 or t1, t2 again. After take the other two different limits, t1 to t2. Here it is y equal to. So this pi into x square. X square is ft whole square, whatever it is, into this is d by dt into dt. D by dt is, let me write here, this is t1 to t2. This is ft whole square into d by dt is g dash t, that you write into dt. This is the volume in case of, these are two equations in case of parametric equations. Okay, so this we will deal with in next one of the lecture series. Okay, because today I am talking about Cartesian form, Cartesian equations here. These are the Cartesian equations I've taken. Volume of solids of revolution of Cartesian equations. And then if it is given in polar form, suppose in case of polar form, let me just describe them, all the three kinds. Then I'll take them, this is the definition part. In case of a curve given in polar form, curve given in polar form, then let r equal to f theta. It is given to us, r equal to f theta. Okay, in this case, what we write, x equal to r cos theta and y equal to r sin theta. These are the polar forms of the equation. So that means the volume of the solid, therefore the volume of the solid, volume of the solid generated by, the same thing we will write, generated by revolving that area or that curve around the axis of x. Okay, and in this case the initial line, around the initial line, generated by revolving the curve around the initial line. In this case, around the initial line where theta equal to 0. So your limits would be 0 to, you take 0 to, let me take theta here, and here in this case pi into y square, which we were doing. Okay, this was dx, so dx d theta into d theta, right here. Now pi by square means 0 to theta. Limits are taken here. Here a to b, there were limits, but I've just converted that into polar form. 0 to theta, limits are taken, and pi into y square is this r cos theta. Y is r cos theta square into dx d theta is this dd theta of r sin theta into d theta. So r sin theta is differentiated, so that we will write in this case in the form of polar form. This is one of the polar forms here. Okay, and if it is pi into x square, then the reverse is there. Okay, so that is the point. That is not going to make a difference. So this is the polar form. This we will discuss when we are taking the polar equations. Okay, but today I am talking about Cartesian equations. Now what are these equations are taken in form of Cartesian equation form. First question I'll do, and same process will be applied in other questions also. All these questions are taken from students' queries, as I always say, but mostly I've selected a lot of questions are there. I've selected these questions, a few questions from students' queries. Thousands of queries are there, but just I'm taking the important ones so that the basics of the topic are clear. Okay, basics are clear, then anyone can do the questions similarly. Okay, so that is my main objective here. My main objective is just to illustrate the points, illustrate the topics, the basics, so that one can understand the basics of this topic. Then one can do the questions very easily, can score very high marks in their respective syllabus. Okay, in the respective papers here. Now let me take question number 1. What does it say? Now it says the area of the parabola y square equal to 4ax lying between the vertex and the latest rectum is revolved about the x-axis. Find the volume generator. Find the volume generator. Now in this case the parabola is given to us. Let me draw the parabola here. Now this is the parabola. Okay, this is the x-axis, y-axis, axis dash, and this is origin, this is y dash axis or y-axis. Okay, we have taken, this is the vertex here. Now it says the vertex and the vertex is having 0 point. This is 0 point here, and at the latest rectum, this point is a here, a0, and at the latest rectum it is a to 2a. The total length of the latest rectum is 4a. This we have discussed in the conic section part, parabola, hyperbola, ellipse. All these three are discussed in conic section. Okay, in geometry part. So that are discussed in geometry part. So that I'll discuss there. Or if one wants to see, then one has to wait, because still that I have not done. But mostly I teach in that topic, conic sections, in case of engineering students. Okay, or in the BSc students. Now let me talk about this. So the volume generated by a solid, this is elementary step I have taken. This is dx here. Let me take m n. This is p and q point. I always take this elementary step. Now this elementary step is revolved around this. Then a solid figure is obtained. Okay, circular part, because area of the circle is pi r square. This is circular form obtained, and that circular form is extended from this point to this point. The total solid line between this point 0 to a we will talk about, because it's x-axis here. That volume